Hello and welcome to a general overview of IOGRAM. In this video, I will go over the basics of the editor, how to create and manipulate nodes, and also how to export the project as a standalone app for Windows and WebGL. So after you've launched the editor, you will be shown the project selection menu here, where you can select an existing project or create a new one. So for this demo, I'm going to create a new project called Mesh. I'm going to call it Getting Started. Once I've created the project, the editor will show you some default views. This big blue square in the middle here is the 3D view, which you can manipulate using some standard 3D orbiting operations. In this case, if I right-click and drag, I orbit the view. If I hit Control and right mouse button click, I can zoom, and Shift and right mouse button click will pan the view. Over on the right-hand side here, the other big view is the graph view. This is the graph editor. On top of it are two library views where we can see different kinds of components. In the bottom left corner of the screen, we have a file explorer view where you can sort of manipulate the file system. And beside it are is a build settings view. And we'll get to all that in a minute. If you want to bring up the project selection menu again, you can hit the home button at the top left-hand corner of the screen. So I'm going to open the same project. In the top middle of the editor are some global controls for the project. This allows you to reload the same project. This saves all aspects of the project. This does a full solve of the graph, and this does a quick solve. To manipulate the different regions of the views, you can click and left mouse button drag in the little divider between the views. And you can see that this has a pretty distinctive behavior. And that's because the views are created according to a kind of sort of recursive splitting method. You can create new views by clicking in the top right-hand corner of an existing view, choosing a split option, either horizontal or vertical, and then selecting the type of view that you would like to have here. So in this case, I'm going to create a little console view. So not much is happening in the console right now because we don't have any errors. If I want to delete that view, I will click in the top right-hand corner of the view, hit the little delete button, and that will unsplit the view back to what I had before. The editor is very customizable, but for this project, we're just going to stick with this layout. Okay, so the first thing we want to do is get a model into the project and on screen. So in one of the library views, we will search for read triangle. This gives us the component read triangle mesh, which we're going to drag and drop onto the graph view. So to do this, we hover over the icon and we left click and drag and release the left mouse button once we're over top of the graph component view. You can click the components in the graph view and move them around. So by default, the read triangle mesh component attempts to load in the file called bumpy.off. And as output, it gives a data structure called a variant map. So it doesn't matter really what that is right now, but the point is that by right-clicking on either the inputs or the outputs, you can inspect and sometimes edit the contents of those input or output slots. So this component has successfully read a triangle mesh. However, there's nothing on screen. And this is because we need a mesh renderer. So we're going to search for mesh renderer. And we find a component called mesh renderer. We drag and drop it onto the canvas. We can then hook up the mesh output of the triangle mesh component to the mesh renderer. And you can see that we have this model bumpy.off rendered in the 3D view. It is often convenient to use the keyboard shortcut for the mesh renderer, which is Alt-M. So first I'm going to delete this existing mesh renderer by selecting it and hitting delete. This also deletes the connection to the read triangle mesh. And then I'm going to put my cursor where I want the mesh renderer, and I'm going to hit Alt-M, and the mesh renderer will appear. This is a very common pattern in IOGRAM where we separate the creation of data and the visualization of that data into two different components. Okay, so in this case, we have read in bumpy.off, and we have visualized, we have rendered that mesh into the 3D view. Okay, we don't only have to use bumpy.off. We can use another file that we have anywhere on disk if we want. So for this, I'm going to go and find a file called Cheburashka here. You can use a wide variety of mesh formats, but here we're going to use the OFF format again. So I'm going to control copy and then go back into my project folder. And I'm going to put this model into the models folder of my current project. Paste this. You can see that it has read in the Cheburashka file, has rendered it on screen. Okay, so in this little not very exciting app, we are going to expose the control of what mesh you want to read to the user. So to do this, we need to go find some input components. So if we type input into the search menu, we get a whole category of components. And in particular, we're going to use the line edit components. So first we're going to drag a screen line edit component, and you can see that creates a little area where I can type text. And then we're also going to use the line edit listener component. And this is another very common IOGRAM pattern where the creation of an element is separated from listening to the actions of that element. So in this case, this component is responsible for the creation of this little text input field, and the listener is responsible for knowing when the text has changed and outputting the value of that text. And you can see that here, if I right-click the values, it says that the value of that text field is hello. So now I can simply hook up the values field to my triangle mesh file input, and it will attempt to read that file and render it to screen. However, there's no file called hello on disk, so if I change it to bumpy.off, you can see the resulting file. So notice that at first I couldn't see the model that was loaded in. That's because the view wasn't centered on the model. To center the view and zoom extents, I use the keyboard shortcut Control-E. I load Cheburashka, you can see that I get that model back here too. Okay, so at this point we're going to save our project by clicking the save icon here. And we're going to do one more thing where we're going to expose a slider to the user, and we're going to perform a geometrical manipulation with that slider. So if I search for slider, then I will get a screen slider component, which I'm going to drag over here, and also the slider listener component. Okay, but we have a problem because the slider component is now overlapping the text field. You can manually position these user interface elements using the inputs. However, it's often much easier to use the screen container element. This is an element that gives a little grouping mechanism to the subsequent UI elements. And you can see that once I pass screen container to the line edit and the slider, it organizes the whole region quite nicely. And you can drag this around. Okay, so now that I have both a slider and a text input, I'm just going to resize this a little bit so that I can see everything. I'm going to save this project, and I'm going to use this slider to manipulate the model that was specified in the text field here. Okay. So what I'd like to do is I'm going to go to the mesh components, and I'm going to grab the mesh frame. There are lots of kinds of operations you can do with meshes here, but we're just going to focus on the mesh frame component. I'm going to connect the output of the read triangle mesh to the frame component, and then I'm going to hook up the output of the frame component to the renderer. And you can see that because we have a default value of 0.2, this operation was performed successfully, and we could render the results. So to tie this into the user interface slider, I'm going to connect the slider values to the inset factor here. But now we have another problem, and that is that the slider option is not giving it a reasonable range to the mesh frame. So a mesh frame goes from 0 to 1. So all we want to do is adjust the range of this input to go from, say, something like 0.01 to 1. And now we can adjust the slider and adjust the frame component appropriately. Okay, so at this point, I'm going to save my project, and my little app that takes an arbitrary triangle mesh as input and exposes a slider to the user and provides this framing mechanism is done. And I'd like to export this out to something a little bit more standalone. So to do this, I go down to the Build Settings window, and it will prompt me to fill out some information. I'm just going to leave all this exactly the same. And in the target field, it will prompt me to specify a destination target. And so in the first case, I'm going to build out to Windows 64, which is already selected. So I'm going to hit build, and when it's done, which doesn't take very long, in the root of my project folder, which is getting started, a new folder will have appeared called My Build. You can see there's an exe file in here and compressed versions of the data in the core data folder. This is why all the assets that you want accessible to the app, or you want to guarantee are accessible to the app, have to be in your assets folder. And so when I double click and run this app, and let's go with Cheburashka this time. Let's see that the Cheburashka has been loaded and framed with this value. Okay, and that's it. You can send this app off to anybody that runs a Windows 64 system. Okay, so the next thing I want to do is get this project running in a browser. To do that, I simply have to change the target from Windows 64 to WebGL. So then I'll hit build. And once that build is finished, you'll see a couple more files in the My Build folder that have to do with loading the player and the resources into the browser. But basically, you just have to point your browser to IOGRAM-player.html. So to show you this, I will just very quickly run a simple web server here. You can see that it's serving 48,000. And go to my localhost. And once it's finished loading the assets, you can see the same window that was present in the desktop build. So for this, I'm going to load .ff. And I'm going to adjust the frame amount. And now we have a little web app that takes a user-defined model and performs a frame operation on that model. Okay, and that is it for the first project with IOGRAM. Thanks very much.